So I was explaining you that how these things are working in the oil and gas field. So if you see in front of you that the exploration has been, how this exploration is done. So there are three types of um, sand surveys, or the things that we are having. So the first one is the anticline, then comes the fault, then the salt dome. In all these three, so you see different phases, so you see different pictures. So how it happens is that they start drilling, they put inside the tubing. So in the anticline, so you'll do the drilling straight away in the down. So the pressure downstream is very high. So once you start drilling, the pressure will start releasing upward side, so the material will start moving from the downward to upward condition. Based on that, the material flows from higher pressure to lower pressure. The same thing is for the fault line. For the fault lines, you probably need to dig it up into the two different tubings. So you'll do the two different tubings in the two different phases. So what you will do is that you will be having two different pressures. As you can see on your far right corner, that one of the tubing is operating at 20 megapascal and the other one is operating at 40 megapascal. The hydrostatic pressure is different. So once that has been digged, due to the high pressure, it will move upwards. So it will be a natural lift that we know. We say in the oil and gas field, it is a natural lift or natural reservoir. So it does not need any pressure gradient that we have to increase, and we have to generate motive force, or the force that will allow the oil or gas to come out of the reservoir. Secondly, if you see here that we have shown the gas in the red, oil in the green, and the water in the blue. Then the rocks are segregated into porous rock and the impermeable rock. Porous rock is usually the sandstone that you might have heard in the earlier video. In the impermeable rock, the impermeable rocks are the barrier stones. So barrier stones are the stones, those are very intacted and they have less porosity in them. In the porous rock, if you see the pictures of the porous rock, I'll show you in the later on videos, the sandstones, they are quite porous. The best reservoirs that we consider are that they they initially operate with their natural lift, and later on, to have an enhanced oil recovery, so we use a couple of other methods. So the first method that we use for the enhanced oil recovery is when we see that the reservoir pressure is depleting, so we start injecting the water inside the reservoir. So due to the density difference, the water will settle down underneath in all that reservoir, so it will start uplifting the oil upward direction. Second option that we use, the recent one, is the gas lift injection. So what we do is we add up the gas inside the reservoir. That gas mixes up with the oil and the other material, or the condensate, or the multi-phase that is available over there, so it will start increasing the pressure of that one. The third option for the enhanced oil recovery we use is the submersible pumps. That is that we put a pump that is submerged inside the reservoir, and it generates a pressure. It gives an artificial lift for the liquid, or whatsoever is the multi-phase available over there, to get it out of the reservoir. Now in the next slide, so there are two types of wells that we can classify in the oil and gas sector. One is the production well, the second one is the injection wells. So we, if you see in this picture, so we have the conductor casing, that is this one. So this is the tubing that we are having over here. Packer is available in